Okay, welcome. And now we're going to do another example, and this one involves harmonic motion again. And so I'm going to describe the situation, and then I'm going to show you how to do it. So in this case, we're talking about the London Eye, which is a huge Ferris wheel, and it gives us the diameter of the Ferris wheel, which is 135 meters, and it completes one rotation every 30 minutes, and riders board from a platform 2 meters above the ground. So express the rider's height above the ground as a function of time in minutes. So what I did was I sketched a graph because, again, this is very similar to the last example I did. So we're going to have this up and down oscillating motion when we're talking about height. The only difference is we're talking about time, right? So now instead of being a function of the angle, now we're saying a function of time, okay? And the height, the y-axis is height. So now the thing is that, in fact, well, I don't need this is just to give you an idea of what's going on. So here's the thing. The x-axis is time, so now instead of defining period as far as the minimum length, right, that the function repeats itself, now we're going to say it's the minimum amount of time by when the point reaches back to its original position, its starting position. So in this case here, again, just like in the last example, we've got a Ferris wheel, right? So we've got a Ferris wheel, and the passengers get on at the very bottom, and then it rotates. Okay, and it takes 30 minutes to do one rotation. Well, that 30 minutes is the period, right? Because one revolution is 2 pi, right? It's going around 2 pi. So that means the period of this ride, this Ferris wheel, is 30 minutes. That's the period. Okay, so every 30 minutes it's going to go back. So it has a starting position, and then it's going to go all the way around, and then it's going to start the pattern again every 30 minutes. So that means it's going to go, if you divide it by 4, right, so every quarter of a turn, it's going to take a quarter of 30 minutes. Okay, so 7.5 minutes. Okay, so now, what can we do what information can we glean from the information that they gave us? Well, let's talk about amplitude, right? So amplitude is going to be what? Well, the diameter is 135, so the amplitude is going to be half of that, which is going to be 69.5. Or no, 67.5. Right, so that'll be 67.5 meters is the amplitude. So half the diameter. Okay, now, since this Ferris wheel is above the ground, right, so we need to find what the vertical shift is going to be if we're going to represent this on a graph. Well, the vertical shift is going to be how high the center is above the ground. Well, we need to know where the center is located. That's the midline, right? The midline of our sinusoidal curve is going to tell us the shift. So D, right? So D, oh, by the way, it starts 2 feet above, or 2 meters above the ground, right? The people are getting on a platform that's already 2 meters above the ground. So again, this is the height of the person, the height of the people, the height of the passengers. So whatever the midline is, that's the height that, that's where the center of the Ferris wheel is located. That's going to tell us our shift. But the center of the Ferris wheel isn't the same as the amplitude, right? Because the wheel isn't sitting on the ground, right? It's sitting 2 feet above the ground. So that means we're going to add 2 more meters, or excuse me, I said feet, I mean meters. We're going to add 2 more meters to the amplitude, right? We're going to add 2 more meters to the midline. Okay, so that means that D, the vertical shift of the height, is actually going to be 69.5 meters, not 67.5 meters. Okay, so now we also know that this is going to be a cosine curve because, again, just like in the last problem, they're starting at a minimum value, right? So the height is at a minimum of 2 meters. Okay, and then it's going to go to a maximum height of what? 137 meters. Okay. So at the starting point, at t equals 0, it's already going to be at a minimum point, and then it's going to go up from there. So it's going to be a cosine curve would be the simplest one to use. And it's going to be inverted, just like the last problem, because it's starting at a minimum point, not a maximum. So that means A is going to be negative. Okay, so now if we put this together, now there's no horizontal shift, so we don't have to worry about that. Okay, now, the period is 30 minutes. So, B, right? So again, the period equals 30 minutes, but P is equal to what? 2 pi over B. Which means, of course, and it makes sense because if you look at 1 revolution per 30 seconds, that's the same as 2 pi, or excuse me, not 30 seconds, 30 minutes, over 30 minutes. Okay, well, if you solve for B, right, by interchanging these two, we get B is equal to 2 pi over 30, or pi over 15. And there's our B. So now we've got everything we need. So guess what? The function of time, f of time, is represented by negative 67.5 meters. Oh, I don't want the units, but the units are in meters. Negative 67.5 times cosine of what? Pi over 15 t plus 69.5, and there's our function that represents the path, or the height rather, it represents the height. In fact, instead of function, let's just use h of t, since we used h in our diagram. Okay. Now, again, just incidentally, I just wrote this on here just to give an idea. So obviously, this is a sine curve. So again, don't get confused with my picture. I just drew that on there to kind of give us something to look at, as far as relating time and height. Okay, but that's the final answer. Have a great day.